this course is about cardiovascular fluid mechanics. So, as you know, what is a cardiovascular system? In the cardiovascular system is inside our body, which includes heart and the various veins and arteries which carry the blood from the heart to different parts of the body and bring them back to the heart. From an engineer's perspective, a cardiovascular system is a piping network in which the flow is being pumped by the heart. From biomedical perspective, there are number of applications where one need to understand the fluid mechanics or the flow behavior inside the arteries and veins. For example, all of us know the heart attack is a very common problem in India as well as all over the world. And the problem is caused by choking of the coronary artery which supplies blood to the heart itself. So if you are a biomedical engineer or if you are a mechanical engineer developing the biomedical devices for such applications, then of course you need to have a good understanding of the cardiovascular fluid mechanics. So for a biomedical engineer or for a biosciences and bioengineering student, it is important to have an understanding of the flow in cardiovascular system. This course is for about 10 hours and it will be useful for the undergraduate as well as postgraduate and research students who are either studying biomedical engineering, biosciences, or have an interest in biosciences and bioengineering. So, for example, the students from chemical and mechanical engineering. In this course, we expect that the student would have done a basic course on fluid mechanics at the undergraduate level of engineering. So he would be familiar with what continuum equations are, for example, what is mass conservation and momentum conservation equations, what is a Navier-Stokes equation, what is flow, a fully developed flow in a pipe. Of course, he will also have knowledge of inviscid flow where, for example, the Bernoulli's equation where he can obtain a relationship between pressure and velocity, neglecting the viscous lossage. So what this will course cover? The course will quickly talk about the physiological system of cardiovascular system, because that is what we are going to study. So first we need to understand the cardiovascular system, the physiology of the cardiovascular system briefly. So we need to understand first the property of the fluid that is being pumped, and blood is a complex fluid. It has a number of flexible particles suspended in it, white blood cells, red blood cells and platelets, and their volume fraction is more than is about 50% and they are suspended in plasma. So we need to understand the rheology of blood. Rheology is basically the relationship between stress and strain rate, that is when a force is applied on a fluid, how does it respond to it, what is its rheological or flow behavior. So that is the first thing that we will study, rheological behavior of blood. Then we need to understand the pipes or the piping network, which is arteries and veins in this case. What is the properties and characteristics of those? So as you can guess that the arteries and pipes or arteries and veins in which the flow happens, they are not the rigid tubes as we generally consider in a conventional fluid mechanics course. So one need to take into account the flexibility of pipe plus The another complexity or another point that is different in the cardiovascular system is that the flow is not steady. This is not the case in a cardiovascular system, because the flow is pulsatile, and we need to understand the pulsatility of the system. Then the flow bifurcates several times. The flow comes out of heart, and from it comes to a aorta or a bigger artery, and from there it bifurcates into different parts of the body. So we need to understand the bifurcating flow and the effect of curvature. So these are some of the topics that we will cover in this 10 hours lecture. Hope you would be able to learn and try to understand or try to apply by the end of this course, try to apply the fluid mechanics concept to understand the biological system. Thank you.